How are you, my friends? This is Basic Math Terms, Part 23, about trigonometric identities. These terms are coming from lectures 20 to 24 from Pre-Calculus course. The terms are identity, cofunction identities, verify, even trigonometric functions and odd trigonometric functions, sum and difference formulas, reduction identity. This is very important in lecture number 22, reduction identity, double angle identities, lowering powers formulas, and half angle identities. You can always refer to this playlist for other parts, please. What is a trigonometric identity? The word identity is an equation that is always true for all values of the variables. Like we have in algebra, we have seen x squared minus 9. You can write it as x minus 3, x plus 3. So the solution here is all real numbers. So we can call this an identity. Trigonometric identity is an identity involving trigonometric functions like 1 over sine squared of x plus 1 over cosine squared of x is equal to plus tan squared of x plus cotan squared of x. You can show that this is true identity. Now look here, sine of x plus cosine of x is equal to 1. This is not an identity because it is not always true. Sometimes it is true, but it should be always true. Cofunction identities. We have 6 formulas here. We call them cofunction. So we can switch from sine to cosine and vice versa here. We can switch from tan to cotan or cotan to tan. We can switch secant to cosecant by these formulas. Sine pi over 2 minus x will be cosine of x. And you can replace pi over 2 here by 90 degrees. See, look at this example here. If we have cosine 75, see, this is cosine of x. Look at this example here, cosine 75. So I can put here in the x 75, 90 minus 75 is 15. So cosine 75 degrees, the value is the same as sine 15 degrees. You can use that in any question you like. Or cotan 22 degrees. So I can put here 22 degrees, put it there. 90 minus 22 degrees will be tan 68. And also cosecant 50 will be secant 40. Now, trigonometric identities, to show that they are equal, they are correct on both sides, you can use these ideas. See, like this one, I'll show you this example here, nice example here. If I say verify, verify means show this side, the left side is equal to the right side. It should be an identity. So you can start with one side and show it is equal to the other side. Start with the one that's little more complicated. So these are ideas that will help you how to show and how to verify trigonometric identities. If you have a fraction like this, a plus b divided by c, you can split it into a over c plus b over c. These are all sines and cosines and other trigonometric functions. Sometimes we can use factoring, or you can use the formulas that we know. Number 4, you can rewrite everything in terms of sines and cosines. So everything you can change it to sines and cosines. Number 5, you can combine fractions. If you have a fraction like 1 over a plus 1 over b, make the LCD AB. Here multiply by b and b, multiply here by a and a. So it will be b plus a divided by ab, then you can proceed. Or you can multiply by the conjugate. If you have like sine x plus cosine of x, the conjugate will be sine of x minus cosine of x. Let's look at even and odd functions. Even trigonometric functions are cosine and secant, because cosine of minus x will be cosine of the x, according to the definition of even function. Secant of minus x will be secant of x. So these two are even functions. The other functions are odd trigonometric functions. The sine of minus x will be minus sine of x, tan of minus x will be minus tan of x, cosecant of minus x will be minus cosecant of x, and cotan of minus x will be minus cotan of x. Addition and subtraction formulas. You have to know these. Addition means when we have the sum of two angles, sine of u plus v, or sine of a plus b, or sine of x plus y, or sine of alpha plus beta. We can use this formula here, number one. I think you know the formula. Here we are explaining only the terms. Sine of the difference, u minus v, will be sine of the u cosine of the v minus cosine of the u sine of the v, the second angle. Now the formulas for the cosine of the sum, that's an addition of two angles, cosine of the difference. These are the formulas. And the formulas for tangent will be tan of u plus v will be tan of u, the first angle, plus tan of v divided by 1 minus tan of u times tan of v. And this is tan of the difference, similar to number 5. Now, if you need cosecant of the sum, there is no direct formula for cosecant of the sum, but you can use the reciprocal, 1 over sine u plus v. And we know sine u plus v, sine of u cosine of v plus cosine of u sine of v, it will be 1 over all that. Same thing for secant, secant of u plus v, the reciprocal of cosine. And the cotan of u plus v, it will be 1 over tan of u plus v. If you need cotan of u minus v, so you know what to do, 1 over tan u minus v, then you can use the formula for tan u minus v. Reduction identity is an important identity. Reduction means the verb here, reduce. So we make it smaller. Reduce what? We have the sums of sines and cosines here. A sine of x plus b cosine of x. See, that's an expression here. We can reduce it. Reduce, reduction. Reduce it, make it only sine function. So we can write a sine of x plus b cosine of x as k, and this is k here in the yellow, k sine x plus phi. X is the same argument here, and phi you have to find from these two expressions here. Sine of phi will be b over k, cosine of the phi will be a over k. Remember, a, capital A here, is the coefficient of the sine of x, and b is the coefficient of the cosine of the x. I have prepared here an example on reduction identity. See, this is a nice example, simple, straightforward. Write the function f of x minus 2 sine of x plus 2 square root of 3 cosine of x as a single sine function. So reduce it, make it one sine function. So here you can read at your leisure time. You can find capital A, capital B. From there you can find k, and then you find sine of phi b over k, cosine of phi a over k. From these two, you can find the angle in quadrant 2 because the cosine is negative and the sine here is positive. So a reference angle will be pi over 3, and phi will be in quadrant 2 pi minus pi over 3, which is 2 pi over 3. See, all this given here, you see all this given, you can write it as this function, 4 sine x plus 2 pi over 3. Then you can graph it, and you can find anything you like. This is all the double angle formulas. One formula for sine of 2x, 2 sine of x cosine of x. Sometimes we write sine 2 theta. It will be 2 sine of theta cosine of theta. The cosine of the double angle, we have 3 formulas. You have to know that. One formula, cosine squared of x minus sine squared of x. Another one only, it contains cosine here. And the third one here, it contains only the sine. Tangent of double angle tan of 2x will be 2 tan of x divided by 1 minus tan squared of x. Also, you can still use tan 2 theta as old formula, remember? The quotient, sine of 2 theta divided by cosine of 2 theta. If you have what is the answer for sine 2 theta and what is the answer for cosine 2 theta. Otherwise, you can use this one here. Lowering powers, this is 3 formulas. I will call them lowering power, LP1, LP2, LP3. When you have sine squared, see from the double angle here, cosine of 2x, 1 minus 2 sine squared of x. LP1 will be, you find sine squared, it will be 1 minus cosine of 2x divided by 2. Now LP2 will be cosine squared of x, 1 plus cosine of 2x. Remember, here is x and here is the double, 2x. But here we have a squared, and this is lowering power. This is power 1 in the cosine. If you need tan squared of x, will be division of sine squared of x divided by cosine squared of x will be 1 minus cosine of 2x divided by 1 plus cosine of 2x. Now, there's another example here, nice example about lowering powers. Express sine squared of x times here, should be times, cosine squared of x as a plus b cosine c of x. Find a times b times c. So first you have to use sine squared from the lowering power. You have to use cosine squared from the lowering power, then you multiply them. You can also read all these details. So this is sine squared times cosine squared. Put the lowering power LP1, LP2, multiply them. Then inside you will have cosine squared here. You see, cosine squared of 2x. You can use the lowering power LP2 again. Cosine squared of 2x will be 1 plus cosine of 4x. See, this is 2x becomes double of 2x, 4x. And here we have 1x becomes 2x. And then when you multiply, you add the fractions, you will get 1 over 8 minus 1 over 8 cosine of 4x. So this is a 1 over 8, b minus 1 over 8, and c is 4. So when you multiply all these numbers, you will get minus 1 over 16. Half angle identities, we have one formula for half angle. Sine u over 2 will be plus or minus square root of 1 plus cosine of u. So you take this u only, put it there, divided by 2. Plus or minus, I will explain now. Cosine of half angle will be cosine of u over 2, will be plus or minus the square root of 1 plus cosine of u divided by 2. Also, the first formula here in tangent half angle, we have formula 3, formula 4, formula 5. 4 and 5, there is no plus and minus. So only if you use formula number 3, you have to choose plus or minus. Let me explain it now. Signs, pluses or minus, depend on the quadrant in which u over 2 lies. Remember, not u. U can be in a quadrant, u over 2 in another quadrant. So here you check the first one in the sine half angle. Plus or minus, where is u over 2? Not u. Same thing for cosine u over 2. Same thing for tan u over 2. So you check where is u over 2 in which quadrant, then you choose the plus or minus. If you use number 4, tan u over 2 will be only sine of u divided by 1 plus cosine of u. There is no need for any pluses or minuses in 4 and 5. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.